In this video, we're going to talk through the worked out solutions to final exam review number 4 for semester 2 of Algebra 1. Looking at number 1, we're dealing with family of functions. To decide the family, I got to look at the pattern. So we're adding 1 each time for x. And as I look here, I see there's symmetry, so I'm deciding, okay, is it absolute value or is it quadratic? So let's look at the pattern. Here, I add 5, and then I subtract 5, and I keep subtracting 5. So because it's the same rate, I know that this is absolute value. For the equation, I remember the absolute value is always y equals a times the absolute value of x minus h plus k, where h and k come from the vertex. So here is my vertex, and my a is the rate. So it's either the 5 or the negative 5. So to think through this, I know that I'm increasing, which means I'm going up, and then decreasing. So this is going to be a V-shaped graph opening down. So I know that the a is negative, so that'll be a negative 5 for a, x minus 2 plus 9. The y-intercept is always when x is 0. So when x equals 0. So when I'm looking at this, well, x equals 0 one more time over here. We're symmetrical, so this would be a negative 1. So our y-intercept is 0, negative 1. Or I could have looked at the equation and substituted 0 in for x and simplified the expression. The transformations of this function from its parent function, well, a is negative 5, so that means there will be a reflection in the x-axis. Because it's negative, because it's a 5, this is going to be narrower than the parent function, or a vertical stretch. And because it's minus 2, we're going to translate to the right 2. And because it's plus 9, we're going to translate up 9. Switching over here, the next family, we're looking at this graph. And because this is an exponential curve, it approaches the x-axis and never crosses it. I know it's an exponential function. To write the equation of an exponential function, I like looking at a table, so I'm going to make a table over here. We have our x values and y values. I see that we have 0, 1, 1, 2, 2, 4, and 3, 8. So as x increases by 1 each time, I'm seeing that my y values are doubling or being multiplied by 2. So my equation is y equals a, where I get the y-intercepts when it's 1, I don't have to write it, times b, or the common ratio, to the x power. The y-intercept I can see from the graph or the table is 0, 1. The domain, well, I'm looking at this, the graph goes forever to the left and right, so the domain is all real numbers. The range are the possible y values. Now I know this graph is going to approach 0, but it's never going to cross 0, and it's anything above that. So I know it's anything above, but not equal to 0. So you won't see an equal to here, and that's important. Moving on to Unit 5. Unit 5 is exponential, so we have to simplify exponential expressions. When I look at this first expression, I know it's not simplified because I have a negative, so I'm going to take care of this negative first. I know I can move the negative to the bottom and make it positive, so this will become 6a on top. This b will stay on the bottom, and this b to the negative third will become b to the positive third in the bottom. Well, b times b to the third is really b to the fourth. And now if I can simplify anything else, I would, but I can't simplify the a and the b because they don't have the same base. So that is my final answer. Switching over to Unit 6, absolute value. I want to solve the equation. I know to solve an absolute value equation, I have to isolate the absolute value bar. So I'm first going to add 8 to both sides. When I do that, that adds to be 0. I'm left with absolute value of 7x plus 1 equals a 29. So I ignore this and I think, what can I take the absolute value of to get 29? Well, I know the absolute value of 29 is 29, and the absolute value of negative 29 is 29. So what's on the inside is either equal to 29 or it's equal to negative 29. So if I subtract 1 from both sides and then I divide by 7, I get x equals 4. Subtract 1 from both sides and then divide by 7, I get x equals negative 30 over 7. Now I can leave my answer like that because that cannot be simplified. There is no common factor between 30 and 7. Switching down to Unit 7. Convert the function into standard form. This is quadratics. Right now this is an intercept form. To convert it to standard form, I need to multiply all these factors together. So let's go ahead. I can distribute the 3 first and get y equals 3 times x minus 12, still times x plus 4. I can either use the area model or I can use the distributive property. I'm going to go ahead and use the distributive property this time. So 3x times x is a 3x squared. 3x times 4 is plus 12x. Negative 12x times x or sorry, negative 12 times x is a negative 12x. Negative 12 times 4 is a negative 48. So when I combine like terms, I get y equals 3x squared. These add to be 0, so minus 48 is my final answer. All right, so looking here, I get the 3x squared minus 48. Boom. There you go. Scooching over here to number 6. Which is a factor of this? Well, if I'm asking for which one is a factor, it means I need to write in factored form. First step in factoring is the GCF, or the greatest common factor. The greatest common factor of these three terms is 1, so I don't even really have to worry about that. I can move on to the next step. I need two things that multiply to be negative 24 and add to be 2. Those two numbers happen to be 6 and a negative 4. I look at the a values, not 1, so I'm going to do factor by grouping, and I can do that using the box if I would like. First term and then last term, 6x, negative 4x, and now I factor out the GCF here. GCF in that row is x times 3x is 3x squared, x times the negative 4 is negative 4x. The GCF in this row would just be a 2 times 3x is 6x, 2 times negative 4, negative 8. So my factored form would be x plus 2 times 3x minus 4. So when I look here, that's not going to work. There we go, C. Flipping to the back, number 7 wants me to solve. I look at this and I recognize this is in vertex form. I have something squared and there's no x anywhere else. So I'm going to do inverse operations to isolate what's being squared. So I divide both sides by 7, and I get x minus 5 squared equals 9. To undo the squaring, I'm going to square root, or the inverse of squaring something is square rooting. So I have x minus 5 equals not just 3. I got to remember, when you solve by taking a square root, you got to have the plus or minus, which means now I have two possibilities. X minus 5 equals 3, and x minus 5 equals negative 3. So when I add 5 to both sides, I get x equals 8 and an x equals 2. A lot of people are just going to say that x equals 8, especially when it's multiple choice, but you can't forget that plus or minus. That's really, really important. Scooching over to number 8, find the value of c that would make this a perfect square trinomial. Remember, we said a perfect square trinomial is when you can factor a trinomial to get the same thing in both spots, and then it's that quantity squared, which means these two values have to be the same. So when I'm factoring, I need two things that multiply to be a times c and add to be b. Well, if they're both going to add to be 20 and they're the same number, I know that 10 plus 10 is 20. 10 times 10 is 100. So c must be 100. And again, if I do that, two things that multiply to be 100 and add to be 20, that'd be 10 and 10. I could skip the box or factor by grouping in this case because their a value is 1, and so that is why that's a perfect square trinomial. Scooching on to unit 8. I'm simplifying. I need to look at what operation this is. This is subtraction, which really means it's like a negative 1 times that second set of parentheses. So 3x to the 5th plus 9x minus 7 minus a 5x plus 9x to the 5th plus 7. Now I can combine like terms. I have my 2x to the 5th terms. Those add to be 12x to the 5th. Now I look at my linear terms, or just the plain old x terms. I get plus 4x. And then finally, negative 7 and a positive 7, they add to be 0, so I'm done. Switching over to number 10, it says find the greatest common factor. Well, let's first look at the numbers, 6, 8, and 12. I know 6, that's 1 times 6, or 2 times 3. 8 would be 1 times 8, or 2 times 4. And 12 is 1 times 12, 2 times 6, or 3 times 4. So the greatest the common ones, we got a 1 for all of them, a 2 for all of them, and it looks like that's the only common, so 2 would be the greatest number. We also have an x to the 9th, x to the 7th, and x to the 5th. The most they will have in common is 5 x's, so the GCF will be a 2x to the 5th. So we got C. Switching on to number 11. To simplify this, I'm going to simplify the square root of 64 and the square root of x to the 8th separately. Square root of 64, that's nice. 64 is a perfect square, so that's just 8. So I'm leaning towards B right now. Let's just confirm this. Square root of x to the 8th, if I break that apart into a bunch of perfect squares, there's 8 x's, which means I could have 4 perfect squares, because each one of those is 2. So 2, 4, 6, 8. There's my 8 x's. Square root of x squared is x. Square root of x squared is x. And if I continue this analysis, I'm going to have 4 x's multiplied together, or x to the 4th. So if I simplify that expression, I get 8x to the 4th, which would be B. And then finally, for number 12, To solve this square root equation, I need to do the inverse of square rooting, which is squaring. So when I square both sides, I get x squared equals a negative 3x plus 28, because that squaring just undoes the square rooting. I have an x squared and an x, which tells me this is quadratic, and specifically standard form. So I got to get it equal to 0, so it's in standard form. I'm going to add 3x to both sides, and I'm going to subtract 28 from both sides, and when I do that, I get x squared plus 3x minus 28 equals, these add to be 0, so I have 0. At this point, I need to solve by factoring, or at least try to. So I need two things that multiply to be negative 28 and add to be 3. And those numbers are 7 and negative 4. Because a is 1, I can go right to my factors. And now I solve using zero product property. So we get x equals negative 7 and x equals 4. Now again, I really shouldn't have boxed in these answers because I know when I solve square root equations, I got to check for extraneous solutions. Remember that parabola, the graph is on the side, so that bottom part of the parabola creates some extraneous solutions sometimes. So I check my answers. Is negative 7 equal to the square root of negative 3 times negative 7 plus 28? Well, negative 7 equal, that's the square root of, that'll be a 21 plus 28, or the square root of 49, which is 7. No, that does not work. So any of these with a negative 7 is not going to work, so I'm going to cross out A. Looking over here, let's check 4. 4 equals the square root of negative 3 times 4 plus 28. When I simplify this, that's 4 equals negative 12 plus 28. That's the square root of 16. 16 simplified, or the square root of 16 is 4, so that one works. So x equals 4 is the only solution that works. X equals negative 7 is extraneous. And we are done with review number 4.